if we look at this equation, there's a couple things that need to pop out here. Okay, first thing that you should notice is that you're missing what? You're missing something in this equation. It's not complete. Okay? The next thing you should actually notice right off the bat is that it is not balanced. How can you tell right off the bat that this is not a balanced equation? There's two Ks, also known as potassium, on the product side, and there's only one K on the reactant side. So right away, one of the first things you do when you look at an equation, you can tell right away if it's balanced or not by looking at the different elements to see if they add up. Okay? So, first things first. Let's look at what kind of equation this is. All right? We might not know what the actual molecules are called, but we can actually identify what type of molecule they are. Okay, I want us to look at our reactants. There are how many reactants in this equation? There's 5. There's anybody else? Somebody says 2. Somebody says 6. Okay, a reactant is a molecule. All right, how many molecules are on the reactant side? How many groups of atoms are on the reactant side? There are 2 groups of reactants, right? So we call those molecules. We've got 1 molecule here and 1 molecule here. Okay? Now, what is something that we can actually, what should jump out at us as to what kind of molecules these are? There's some pretty big hints in these 2 molecules to state what they are.
There's an OH in the first one, which would indicate...
Also known as a hydroxide. You need to use your words properly. There is a hydroxide which indicates what?
It's a base.
That it is a base. Yeah, this is a base. OH, base. Okay? What else is in this that indicates something that we know about?
There's an H before SO, so it makes it an acid.
There are actually 2 H's before SO4, right? So SO4 known as sulfate. Okay, so this is sulfuric acid. And we see that it's an acid because it's got those hydrogen ions right before. Okay? Now, knowing that, we know what happens in an acid-base neutralization. So if you get a question like this, you will, you get a question like this, one of the first things you have to do, we have to actually identify what the missing molecule is. Okay? And if we remember what happens in an acid-base neutralization, remember that little jingle, an acid plus a base equals? A salt plus water. Well, if we look at this guy right here, is this water? No. Therefore, what is that? That will be your salt. Okay? So what am I missing in this equation? I am missing water. Exactly. I'm going to write my H2O in here. Now I've got the full equation so I can balance. You've got to get your full equation first. Where did the H2O come from? Well, this couple right here broke up. Okay, this couple right here broke up. So these H's and these OH's did not want to hang out with who they were with. They get together. And that's how they form water. And even looking at this molecule, you can tell that it is not balanced. Right now, there's how many OH's? There's only 1 OH. How many H's are there? Okay, well, there's 3 H's together, but if we were just looking at H by itself, not the OH, there's 2 H's and 1 OH. So we know that that's not balanced. Okay, so we'll fix that. Do I have any questions so far as to where we are? We finished our equation. We now have to balance it. So let's talk about the different atoms that are in this chemical equation. What do I have? Tell me. I've got K, potassium. What else? I've got some O's. What else? I got some H's and I've got sulfur. What do I have on this side? I got some K's. I got some O's. Oh, I do have H. And I have S. Okay, how many K's on the reactant side?
1.
I got 1. How many on the product side? 2. Uh-oh. Right away. How many O's do I have here?
5.
You're right, I have 5. I've got 1 here and 4 here, right? For a total of 5. How many O's on this side? 5. Same here. 4 and 1. So that balances. How many H's?
3.
I've got 3 H's here. How many H's?
2.
Yikes. How many S's? 1. There's no bracket here, sweetie, so it's not like the 4 is multiplied by both.
We were all looking at the other side.
Okay? You still don't have. This is all by itself here. It's not, this is 1 unit. So you only have 1 S. All right? Now, we can see clear as day that this is not balanced. Right? We've got some work to do. We know when we balance equations that we cannot add any little subscripts. We know that. The only thing we can add are the big numbers in front of the actual molecules. So how can we actually address this right now? What can we do? What do you think?
Put a 2 in front of the KOH over here.
Okay, so if I've got potassium hydroxide and I put a 2 out here.
But then the rest changes.
Okay, and actually let's do that one in a different color here. Let's pick a really bright one. There we go. Okay, so if I put a 2 here, that means 2 is multiplied by this guy, 2 times this, and 2 times that. So how does this change stuff? How many potassiums do I have?
2.
I now have 2 of these. How many oxygens total on the reactant side? 6, right? O2 plus O4 equals 6. So now I've got 6 of these. How many hydrogens?
4.
I have 4 hydrogens, right? Because H2 plus H2 over here. That's 4 hydrogens. Okay, well, what can I do? How do I balance this out on the product side now? What can I do?
Add a 2 in front of the H2O.
If I add a 2 over here, I multiply this guy, H2 by 2, and I multiply my O by 2. So, how many H's on the product side? 4 H's. And how many O's on the product side? 6, right? Because I've got 4 here, and I now have 2 O's here. So is this balanced?
Yeah.
So this is an example of an acid-base neutralization and a balancing equation. Okay? Now, if this was balanced, if this equation is, what it's supposed to be, so let's write it out here where I've got 2 KOH plus H2SO4 yields K2SO4 plus 2H2O. That is a balanced equation. What if I told you that I had 13 grams of this, 28 grams of that, and I had 18 grams of this. How much water is produced? How can you figure this out? Okay, so say that again.
Take 13 plus 28.
28 plus 13 is going to give me 11. So that's 41. Okay, so if I add these together, I've got 41 grams of reactants. Doesn't matter that I've got 2 KOH, okay, or H2SO4. It means that of the total amount of hydroxide there, I've got 13 grams of powder or pellets or whatever. Okay? And if I've got 28 grams of sulfuric acid, it gives me a total number or total amount of 41 grams of reactants. And if 41 grams of reactants is equal to 18 grams plus X, how do I solve for X? What do I do?
You cross multiply?
No, I don't even have to cross multiply here. It's way easier than that.
You isolate it.
I isolate it by doing what?
You divide.
You don't have to divide. Look at this. You subtract. This comes over to the other side, and it becomes a negative. So we end up with 41 grams minus 18 grams is equal to X, which is equal to what?
23.
23. So 23 plus 18, yeah. That means I'm going to produce 23 grams of water in this balanced equation, in this acid-base neutralization. So we just looked at 3 different topics here in one question. Okay? That's a completely doable question. Do you know your acids and bases?
Yes.
Do you know what a salt has to look like?
Yes.
Can you find out if something is a metal or a nonmetal? What can you look at to make sure that something is a metal or a nonmetal? Periodic table. Because if it's on what side? If it's on the left side of the staircase, what is it?
Metal.
It is a metal. If it's on the right side of the staircase, so all the answers are there in front of you. You just have to know where to look.